In three-dimensional geometry, today we will discuss the topic of point of intersection of two lines. Now, what is point of intersection? Intersection point, let this be x, y, z, is the point that will lie on both the lines. That is, it will satisfy both the equation of the lines. Let's see, for example, we have these two lines. The point of intersection is x, y, z, which is the intersection point that will lie on the first line as well as on the second line. So this is the common point. Now, let the equation of lines be x minus x1 upon e1 equal to y minus y1 upon b1 equal to z minus z1 upon c1. And the equation of second line be x minus x2 upon e2 equal to y minus y2 upon b2 equal to z minus z2 upon c2. These are the equations of the lines of which we have to find out the point of intersection. Now first check whether lines intersect or not. So to check, we will equate the first equation of line equal to lambda and the second equation of line to mu. You can take any other variables also. Either you can take D, E, F, anything. Now, consider the equation of first line. X minus x1 upon a1 equal to y minus y1 upon b1 equal to z minus z1 upon c1. And you equate it to lambda. So first ratio is equal to lambda as well as second ratio is equal to lambda and third ratio is equal to lambda. When you equate the ratios, you will have x equal to x1 plus a1 lambda, y equal to y1 plus b1 lambda, and z equal to z1 plus c1 lambda. So this point x, y, z will lie on this line. That is the first line, and it will be of this form. That is x1 plus a1 lambda, y1 plus b1 lambda, and z1 plus c1 lambda. Similarly, you can consider the second equation of line. Equate the second equation to mu. So x minus x2 upon a2 equal to y minus y2 upon b2 equal to z minus z2 upon c2 equal to mu. So equating all the ratios equal to mu, you will have x equal to x2 plus a2 mu, y equal to y2 plus b2 mu, and z equal to z2 plus c2 mu. So this point x, y, z that lies on second line will be of this form: x2 plus a2 mu, y2 plus b2 mu, z2 plus c2 mu. So x, y, z is the intersection point. Now we can equate the two equations found in first and second. So x1 plus a1 lambda equal to x2 plus a2 mu, y1 plus b1 lambda equal to y2 plus b2 mu, and z1 plus c1 lambda equal to z2 plus c2 mu. And you can mark them as first equation, second equation, and third equation. Now solve equations first, that is this equation, and second equation for lambda and mu. You can use any method. Since there are two variables and linear equation, you can solve the linear equation in two variables using substitution or elimination method. Now, after finding out lambda and mu, substitute the values of lambda and mu in equation 3 and see whether the third equation satisfies or not. That means left hand side is equal to right hand side or not. So if the values satisfy the equation 3, that is this equation, then the lines intersect. Otherwise, the lines will not intersect. So if the equations are satisfied, then the lines intersect. Otherwise, they will not intersect. Now, the point of intersection. If the lines intersect, then you have to find out the point of intersection. So, to find the point, substitute the value of lambda in the point you found in solving equation 1. So, x equal to x1 plus a1 lambda, y equal to y1 plus b1 lambda, z equal to z1 plus c1 lambda. If you substitute the value of lambda, so x, y, z is the required point of intersection.